In this video, we are going to solve Pearson Edexcel International Advanced Level, Thursday, 9 January 2025, afternoon, okay, time 1 hour 30 minutes, WCH11, okay, 01, Chemistry International Advanced, okay, IAL, the paper it is of 80 marks paper and 1 hour and 30 minutes time is required for this. Before starting towards the solution of this, I will request you kindly subscribe my channel and share the video, like the video, and comment on the video if you have any query related to it. Let's start to solve this paper over there. Here, first of all, some questions are given for multiple choice questions over there. You feel aim to spend more than 20 minutes on this section over there. What is the total number of atoms in 8.8 gram of carbon dioxide? So first of all, you will have to need number of moles should be multiplied by Avogadro's constant Na over there. So number of moles means 8.8 divided by 44. So 8.8 divided by 44. So I will say here 8.8 divided by 44 is equal to this is equal to 0.2. So it is 0.2 multiply Avogadro's number 6.02 multiply times power 23. So multiply 6.02 multiply 10 raised to power 23 is equal to 1.204 multiply 10 1.204, that is number of carbon atoms, carbon dioxide 1.204. So it is number of molecules, number of molecules of all carbon atoms will 0.2 multiply 6.02 multiply 10 raised to power 23, which is giving us answer as 1.204. 1.204 multiply 10 raised to power 24. Now he is saying total number of atoms according to molecule carbon dioxide, 2 oxygen atom, 1 carbon, total 3. So just multiply this by 3 over there. So multiply by 3 will equal to 3.16 multiply 10 raised to power 23. 3.16 multiply 10 raised to power 23. 3.16. So it is 3.6 multiplied times power 3 will be the right option, which is considered as B option over there. Okay, 3.6 multiplied 10 raised to power 23. This is the right answer for this one. After that, he is saying how many moles of ions are there in 40 cm cube of solution of this dm cube. First of all, for this one, for how many moles of ions are present. So for this one, we will first have to calculate the moles over there according to the formula. N number of moles is equal to concentration multiply volume. So concentration is 0.05 multiply volume is in cm cube, convert it into dm cube because here it is in dm cube. So divided by 1000, 0.04, and just by multiplying this number of moles will be calculated. So I will say here 0.05 multiply 0.04 and it will equal to 0.2 multiplied 10 to the power minus 3, 2 multiplied 10 raised to the power minus 3, and he is saying how many ions are present. So Mg plus 2 is 1 ion and NO3 is minus 1 with 2 ions. To total 3 ions are present over there. So he said how many moles of ions are present. Just multiply this with 3 over there. You will get 6 multiplied 10 raised to the power minus 3, which will equal to 0.006 over there. So it should be going with option C over there. After that, he is showing here a water molecule containing isotopes of hydrogen and oxygen, and hydrogen 1 and oxygen 16 has the molar mass this. This has mass in grams this. What is the mass of atomic mass unit to be measured in grams over there? So I will say here that the hydrogen mass of hydrogen is 1, mass of oxygen is 16, has mass. He is containing a water molecule. So 1 and 2 and has a mass. A water has a molecule containing isotopes of hydrogen and oxygen. Hydrogen 1 and oxygen 16 has a mass of this. What is the mass of an atomic mass unit measured over there? AR of oxygen is 15.599 and hydrogen is for this one AMU over there. So if I talk about this, then I will say there is two hydrogens are available, which is 1.0080, and we can simply say here that what he has taken over there for water molecule H2O, this is 1, this is 16 over there. Then we can say that overall molecule mass can be given as 2.99 multiplied 10 is power minus 3, 23 like that. Its atomic mass unit is 2 multiply this plus this. So I will take 2 multiply this plus 15.995995, and what the answer which I am getting over here, that is 2 bracket start 1.0080 1.0080 bracket close, and is equal to this plus 15.995 equals to this is equal to 18.011, 18 point where it is 18.011, 18.011. This is in AMU over there for water molecule over there. Then I can say therefore 1 AMU is being given for this mass over there. So 2.9908 multiplied 10 is to power minus 23 divided by 18.011. Let's check what it is coming over there. Then I'm saying 2.9908 multiply 10 raised to power minus 23 divided by answer is equal to 1.66 1.66 multiply 10 raised to power minus 24, 10 raised to power minus 24 over there. 1.6605, you can also above over there 05. So he is going for this one over there. Option C is correct over there. Question number 4, he is saying NXO4 is an oxide of nitrogen. The percentage of mass of oxygen is in the oxide is 69.57%. What is the relative molecular mass of this oxide over there? So for this one, we can say let MR of NOx is M and the mass of oxygen is 69.5%. Mass of percentage of oxygen is 69.5%, 69.57% over there of M, and the mass of nitrogen will definitely 100 minus 69.57. Let's check what it is given. 100 minus 69.57 equals to, that is 30.43, that is 30.43% for nitrogen over there, and the formula is becoming N2O4 because it is almost, we can say, So the mass of oxygen 4 into this 64 can be made over there to get the overall mass of this. So I will say the formula becomes N2O4. If this formula is going to form over there, then I can say, so mass of oxygen will be 4 multiplied 16 will equal to 64. And if your overall mass, if you are talking about that, let's suppose I am taking 64, and for nitrogen, if I talk about that, then nitrogen should be doubled, means 28 should be taken over there. Then I will say it is making 92 over there. So option B will be fine for it. So for question number 4, option B will be perfect. And 64, you can divide it. 64 divided by its percentage, which can be taken by dividing 100 over there, 0.6957 over there. Let's move to question number 5 over there. Here he is saying 4 different solutions contain chloride ions. 3 of the solutions containing the same number of moles of chloride ions. Which solution contains the different numbers over there? So for this one, I can say that he is saying for first of all, calculate the chloride ions, like 1 chloride ion for HCl. If I go for it, then as he is saying HCl, hydrochloric acid, then chloride ion per unit, its volume will be 0.015, because I am taking in dm cube 15 multiplied by 0.80, n is equal to cv is going to be obtained over there, 0.8, 8 times 120, so it is 0.1012. 012 is coming in the form of number of moles over there. After that, 10 cm cube of 40 cm cube dm cube 0.40, so it is 400. So it is being taken with FeCl3, means 3 times chlorine also should be taken over there. So I will say here that after multiplying 0.01 multiply 0.4, and after that I am saying that it should be multiplied by 3, 3 4 12.1.12, so it is 0.012, 0.012 over there again. After that he is saying that 10 cm cube of 0.90 of magnesium chloride. Here you will have to take 2 chloride ions and zero point 0.9, so it is 0.018, 018 over there. And for this one, 20 into 60, 12, so again 0.012. So here I can say what he was asking, 4 different solutions contain chloride ion. 3 of the solutions contain the same number of moles of chloride ions. Which solution contain a different number? So different number is going for option C over there. So answer C, you should keep in mind that the different number of moles it is containing, remaining all to all are having the same number of moles over there. A solution containing 95 gram of 95 parts per million of a solute over there, which mass of solute is dissolved in 1 kg of the solution. 95 gram, 0.95 gram, 0.95, and parts per million. If we talk about that, we know that 95 parts per million is shown over there, means that 95 parts per million by mass. So in 1 kg 1000 gram of solution, mass of solute will become 95 divided by parts per million. So 1 with 1 2 3 4 5 6, 95 will be like that, multiply by 1000 gram. So 3 zeros are gone with 3 zeros. What is remaining? 95 divided by 1000, so 0.095 gram. So it will be option C will be fine for this. I think so. The concept behind it is Much clarified for you. Now he is saying a sample of hydrated magnesium sulfate contains 43% by mass of water. What is the formula of magnesium sulfate over there? So for this one, I will say that we will have to go for proper calculation over there, in which first of all MgSO4 with X water and Mr will be taken 120.4 plus 18 for water and with unknown X, then percentage of water with MR 18 over 120 plus 18 multiply 100% to get 43% over there. And by solving and comparing, you can easily observe that overall, if we say that it will become the water with the 51.77 plus 7.74 is being taken as 57% water. So I will say option B will be perfect for this. I have not done the calculation for this, and I'm just guiding you how we can go for that. I'm saying use the MgSO4 dot X water to make Mr 120.4. 120.4 is being taken, Mg is 24, S is 32 plus 64, and you will get approximately equal to 120.4 over there, and plus take water and remain this a number of molecules of water as unknown as X over there, and after that go with percentage of 43% by mass of water, and take 57% for this magnesium sulfate. You can easily observe that how much the mass has been taken, like that is 120.4. So X multiply 18 over 120 is multiply by 100. Multiply by 100 is equal to 43. Yeah, 43%. So 0, 0, 6, 3 times, 6, 2 times, 2, 5 times. So 43 divided by 15. So 43 divided by 43 divided by 3 and 43%, and answer B is going to be taken with 5 water molecules over there for this question. Okay, for question number 8, he is saying ethanoic acid can be produced by the oxidation of butane. Okay, oxidation of butane is happening. The atom economy by mass for the production of ethanoic acid. Okay, for this one, I will say here that atom of economy, like MR of desired product over MR of reactant multiplied by 100 is called atom economy over there. What I am saying? At MR of desired product divided by MR of all reactants will multiply by 100% over there, will be used to calculate the atom economy. So desired value of MR. So MR of our desired value is this: 12 plus 3, 15, 15 plus 12, so 27, 28, and 32. So it will be 60. It will be 60 as MR of desired product. So 60 multiply by, so total MR of desired product, that is 4 in number, just multiply by 4. So you will get 240 as a product of MR of desired product over there. After that, we will have to go for MR for total reactants over there. For that one, I will say here that the total MR, like 32 multiply 5. So 32 multiply by 5 will equal to 5 2 times 10, 10, and 5 3 15, 160 plus C4H10. 12, 4, 48, 58, 58 multiplied by 2, 116. So 240 divided by multiplied by 100 also. So it is going with fraction introduced 240 divided by 6 and 7 2. Hmm. 2 over there multiply by 100 is equal to this is equal to 86.9%. So 87% like that. So option D will be perfect for this over there. Let's move to the next one for question number 9. Here he is saying the first four ionization energies of the elements of gallium, indium, and germanium and tin are shown. Which values of first four ionization energies of gallium over there? So if I just observe that the gallium is having three valence electrons over there, the first ionization energy is relatively low, removing a p electron, and the second electron of ionization energy is at higher, removing s electron from the partially positive, and this. So I will say A is too low for the fourth ionization energy over there, and A is too low. And C and D show the small jump between third and fourth over there, and typically of group 4 elements over there. So we can say for this one, we should go with answer B over there to be taken into account. Okay, if you just easily compare the ionization energy levels, then you can easily do for this one, where the second ionization energy is higher and the third ionization energy is significantly higher over there, and the fourth ionization energy is very high, like removing a d electron from the stable core over there, and A is too low for the fourth ionization energy. C and D show a small jump between third and fourth, typical, we can say, of group elements of S2P2 like that. Okay, so this is for question number 9. Let's move to question number 10. Sulfur has a higher melting point, melting temperature than white phosphorus. Which is the possible reason for this? So sulfur 8 and sulfur white phosphorus like that, P4, are both molecular structures, and however sulfur has stronger intermolecular forces and stronger forces due to more electrons and potentially some as bonding over their interaction, leading to a higher melting point and than P4. So I will say option A is incorrect because it is saying for non-polar over there. The molecules have a greater permanent dipoles. No, it is non-polar, so it is incorrect. For option B over there, then I can say, however, if we go for B over there, it is vague because intermolecular bond strength is similar. Option C is false. Both are molecular, and D is correct answer for it, that sulfur molecules have more electrons than phosphorus molecules over there. And here we can also add over there. Okay, now he has given us that we should use this space over there for rough working. Anything you write in this space will not no credit over there. Okay, which species are arranged in order of increasing radius over there? So we should just observe here for this question that all are we can say isoelectric, like 18 electrons with krypton, potassium, argon, chloride ion, and bromide ion. If I go for all of them, then I will say that all are isoelectric 18 electrons over there. Radius increases with the decreasing effective nuclear charge like Z-man effect over there. And potassium ions are the most protons like 19 pulling electrons in tightly smallest. AR has 18 protons larger. Chloride ion has 17 protons but 18 electrons, and electrons repulsion may take it larger over there. Bromide ion has one more shell largest over there. So order can be correct is K to AR to CL to BR for all of this. I think so. The reasons which I have told you in by explaining over there will be much more clarified for you. After that, he is saying that which cations would be the most polarizing, radius and charge over there are given. So for this one, small, large, okay, radius and charge. If I want to talk about it, I will say a polarizing cation has a high charge density, and high charge density results from a small radius and a large charge over there. So I will say option A will be fine for this, which he where he is going to explain that all polarizing cations has high charge density, and high charge density, then we can say high charge density results a small radius and a large charge over there. So option A is fine for it. After that, he has given that in the gas phase, PCl5 exists as molecule, and there are trigonal bipyramidal equatorial chloride, axial and equatorial and axial. So each chlorine atom can be replaced one at a time by a fluorine atom. So the two axial chlorine atoms are replaced before the three equatorial atoms. Which of the resulting molecules does not have the permanent dipoles? So we know that for a molecule to have a permanent dipoles, it must be symmetrical. And PCl5, if I observe here, P 1, 2, 3, 4, 5, PCl5 over there is a trigonal bipyramidal and it is nonpolar. So replacing the two axial chlorine atoms with fluorine, two axial with what I'm saying, two axial with fluorine, then I can say if the like what will happen first gives the PCl3 and F2 because it is Cl PCl3 and F2 after replacing will be formed over there. And in trigonal pyramidal, if the two F atoms are both axial, then the molecule is symmetrical and nonpolar. But the question states that the axial atoms are replaced first, so the structure with the two axial F atoms with PCl3 and F2 is symmetrical and has no permanent dipoles over there. So I can say option which one will be most suitable for this. So option B is fine for it. PCl3 and F2 will be fine for it, which it does not have. Okay, does not. Remaining all to all conditions will have their permanent dipoles over there. In question number 14, he is saying which hazard wearing symbol would be found in a bottle of hexane over there. So hexane, I can say hexane is a flammable organic solvent. So the correct symbol is the flame based on standard hazard symbol, and the answer in the flame symbol is option A if A is the flame over there. So this is when hexane is carried out by a bottle, he will be having this symbol over there. Here he is saying the IUPAC name for the hydrocarbon molecule over there. All right. So if we just observe that the first longest continuous charge chain is having 10 carbon atoms like that. So it is 1, 2, 3, 4, 5, 6, 7, 8. and 9. But if I take from here to here, so longest chain is this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 over there. So it is just like a decane as a longest chain which I have taken for this one. And I am saying that I am taking my chain like this to go over there. And for this one, I will say here that the number of the chain to give the lowest number of the methyl groups, carbon 7 and 8 have the methyl groups over there. So this one is having methyl group and this one is having methyl group. So it is 1, 2, 3, 4, 5, 6, 7, and 8 are having the methyl groups over there. So what is he saying over there? That give the name of this product. Okay, right. What is the IUPAC name of this compound? Then I will say it 1 7 8 dimethyl. So it will be 7 8 dimethyl decane with the straight line 10 carbons over there. 8 and 9 and 10 over there will be responsible for arranging it in a sequences way. Which statement about the cracking of crude oil is true? The cracking of crude oil. Okay, so if I explain about cracking of crude oil, then I will say cracking breaks down large hydrocarbon molecules into smaller ones, and this decreases the average number of carbon atoms per molecule over there. So decreases the average number of carbon atoms per molecule over there. Here he is saying that the bromine and bromine water can be used to test for carbon-carbon double bond, which when bromine water reacts with 2-methyl butene, and there is one other major organic product which is produced over there. Okay, which is the skeletal major formula of the product over there. So skeletal formula with bromine and OH will be bromine water adds to the double bond and decolorizes the addition, and I will say that water also adds some adds across the double bond. So I can say here that the major product is the bromohydrin, where bromine and hydroxyl ion and add across the double bond, and for 2-methyl butene the more stable carbocation is tertiary. So I think so it will be much clarified with you, and the bromine will add to the tertiary carbon, and the OH of the other carbon over there. So the correct structure is one with the Br and a tertiary with the carbon with the OH and primary alcohol, and this is likely option C will be fine for this over there. Okay. Which of these formulas are correct to 1,4-diethyl cyclohexene over there? So, okay, for question number 18, he is saying over here that the skeletal formula of name 1,4-dimethyl cyclohexene is incorrect, because if I talk about skeletal formula, if then we say cyclohexene has the double bond network between double bond between C1 and C2. So you cannot have the substituents on C1 and C4 over there will be used. So I will say here that the right option for this one is going to be taken as answer as C over there, that 2 and 3 are perfect. 10 18 and 5 9 molecular formula, and this is correct, but this one is going to damage because alkene should be taken. So 2 and 3 only is correct over there. After that, question number 19, he is saying beta furnace is alarmed phenomenon. pheromone released by aphids over there. How many pi bonds have many sigma bonds are present in this molecule over there? If I just observe pi bonds, one, two, three, four, four pi bonds are available. And if we go for sigma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, and hydrogen should also be being taken over there. And I should go with the maximum, like I should go with 4 pi and 38 sigma over there. You can also calculate by knowing that carbon, 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 and carbon, and carbon, and carbon, 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 carbon. So overall, I can say everyone is being used according to the measurement of calculation of how many bonds are present over there. That will be 4 pi and 38 sigma over there. Which structure is a Z isomer over there? So it's isomer Z isomer. For Z isomer, the high priority groups on each carbon at the double bond are on the same bond over there. And I will say here that that in C, the left carbon at carbon bromine higher productivity is up, and on the right carbon the C and this ring shows the high priority, then hydrogen it's up and same side, and Z isomer is there, so it is being taken as answer as C over there will be most perfect for this answers over there. Okay, this was your MCQ section paper over there. After that, we will have to go for calculations. In the next video, we will start for this section also, and try to revise all of your section till here, which I have done for you in the form of MCQs. Thank you so much. In question number 21, he is telling us that chloroethene, okay, chloroethene and 1-chloropropene are the first two members of homologous series. 1-chloropropene exists as two geometric isomerisms. Okay, draw the displayed formulas for chloroethene and one geometric isomer of chloropropene over there. So let's start to it. So let's go for 1-chloroethene propene and chloroethene over there. So let's draw it now. Uh, First of all, carbon to carbon double bond over there, and it is going for chloroethene. I'm taking Cl with H, and with H will be taken as chloroethene, and 1-chloropropene. If we go for it, then I am saying here 1-chloropropene. This is for chloroethene. Chloropropene will be 1, 2, 3. And then I am saying here that it is carbon to carbon double bond, and it is single with three carbons. 1, 2, 3, H, and H. This is 3 are done, only one H. This is 2 are done, so this is chlorine, and one H is going to be being taken over there. So if I take double bond here, then CH3 will be coming on this side. So both can be taken as chloroethene and chloropropene over there. Explain why chloroethene and one chloropropene are the members of homologous series over there. Then I will say they have the same functional group like carbon to carbon double bond, same functional group over there. They have the same chemical properties over there because they give the addition reactions over there. Chemical properties over there. And I can also say they have the same general formula, like they will have CnH2n, after that plus 1, and plus 1 should be taken, or no, I think so, no, will shall not be taken, plus minus 1 should be taken with Cl, because in general they have the general formula CnH2n, and one hydrogen is replaced with chlorine, then I will say 2n minus 1 with Cl or halogen group as X over there, and each differ by a CH2 group over there. And if I'm making a long chain, everyone is going to differ with one CH2 by its mass to get the next value of the series over there. Okay, here he is saying that explain why one chloropropene exists as two geometric isomers but chloroethene does not. So, because there is a restricted rotation around carbon to carbon double bond and carbon to carbon double bond in both molecules, and one chloropropene has two different groups of each of the carbon atom in double bonds, and but there are two hydrogen atoms on same atoms on one carbon of chloroethene will be being taken according to this phenomenon over there. So we should be able to explain this in detail. Okay, after that he is saying chloroethene and one chloropropene are both monomers. Draw the structure of poly one chloro propene over there. So remember that carbon to carbon double bond will be taken as the broken form of the chain to make like this. Okay, and your Cl group, if you are attaching above, and CH3 up below to show the propene also, just complete their hydrogen and hydrogen over there. This will be your monomer formula structure to display over there. After that, he is saying that the polymer of chloroethene is known as PVC, polyvinyl chloride, is used to make water pipes and gutters, which was previously made of metals. So, just two advantages of using PVC instead of metal pipes of gutters in the uh, other than cost, like they expensive or not expensive. He is saying ignore them over there. Then I will say they are less in weight, less in weight. They means they are lighter. They does not crude or rust. Does not rust, like iron is going starts rusting over there. And one more reason which I can say, like no metal ions get into water supply. No metal ions get into water supply over there. This was your 11 marks question over there. Okay, let's move to 22. Okay, here he is saying that the diagram shows the arrangement of electrons in the energy levels of a sodium atom, N1, N2, N3, N4, N5 up to N infinity. Give the reason why the two electrons in N1 energy level are represented by two arrows and by pointing in opposite direction over there. So we can say it is to show, it is like this one, and this one symbol is to show that electrons are existing in pair, but they have so that electrons are having opposite spin when they are existing in the same subshell over there in the form of pair over there. After that, he is saying explain whether or not all the electrons in N2 energy level have the same energy over there. The sum of electrons are in the S subshell orbital and some electrons are in P subshell. They don't have the same energy because electrons in the P subshell have higher energy. So electrons in S subshell have low energy, P subshell has high energy. So n is 2 over there. For this one, I will say they don't have the same energy because electrons in p subshell orbital have a higher energy over there. Name the shape of the orbital occupied by an electron in the n equal to 3 energy level over there. Then I will say that is mostly spherical or sphere-like shape over there. Spherical shape or sphere-like shape. So I will say never try to draw the diagram like that. It will be ignored. Okay, here he is saying samples of germanium consist of 5 isotopes. Okay. Uh, the fifth isotope germanium is 76. And germanium 76 is radioactive because it is very long half-life over there. This means that the isotopic composition is almost constant and stable over there. Okay, calculate the mass number of the fifth isotope of germanium. The relative atomic mass is 72 point this. So I will say here that the percentages which are given over here is 27.8, 36, 7.8. So germanium as fifth group, if I want to calculate over there, then I will say it is given as 100 minus 20.5 minus 7.8 minus 36.5 minus 7.8 is equal to this, which is equal to 27.4%. So it is 27.4% over there. So if the relative atomic mass, he is given that it is 72.6, okay. 72.6 as relative atomic mass will equal to 70 multiplied by 20.5, 70 multiplied 20.5 plus 73 multiplied 7.8 plus 74 multiplied 36.5 plus 76 multiply 7.8, wait a second, multiply 7.8, and in the last I am saying go with x multiply 27.4 divided by 100. If I arrange all of them and try to calculate my exact value of x, it will be giving us the maximum value of our sixth orbit. So that will be being taken as 72, like 71.59. Just give this to calculator to all of this, then subtract from here and then multiply by 100 and divide by 27.4. You will get this value in the form of x over there, which is approximately being taken as 72 as the fifth isotope over there. Okay, this was your how many marks question? It was 3 marks question. Okay, give the main reason why the answer in A2 should not be quoted to more than two significant figures. Then I will say here that the number of protons and neutrons in a nucleon must be an integer number because number of electrons and protons and neutrons, number of protons and neutrons always exist as an integer value over there. After that, he is saying that the radioactive decay of germanium 76 atoms forms a stable atom of selenium. Compare and contrast the atomic structure of the atom of germanium 76 of an atom of selenium 76 over there. So similarities like both have the same sum of number of protons and neutrons. Both have same mass number. So I can say both have same number of protons plus neutron over there. Differences. An atom of germanium contains germanium 76 contain two more fewer protons than selenium, two more protons over there. So germanium has two less protons than selenium. And I can also say that germanium has two more neutrons. Germanium has two more neutrons than selenium over there. And I can also say the number of atoms of germanium has two fewer electrons. Like germanium has two fewer electrons than neutral atom of selenium over there. Selenium over there. Okay, now we will have to move question number 24 there, where he is saying that a sample of volatile liquid X was vaporized at 473 Kelvin and 110,000 Pascal. 3.50 gram of X occupies 1.79 dm cube. Okay, calculate the moles of X over there. So for this one, I will simply say here that we will have to go for using this equation. PV is equal to nRT and N is equal to PV over RT over there, and P is given 110,123 multiply volume, which is given as 1.79. It is dm cube. It is dm cube. Should I go for cm cube over there? So 1.79. And so I'm saying here that I want to go for this one as in the form of cm cube over there. So volume can be taken as divided by 1000, also divided by R as general gas constant, which is having the value 8.31, multiply temperature will be taken as 273 Kelvin over there. Let's go for number of moles calculation over there. So it is going with the fraction introduced 1, 1, 1, 2, 3, 4 multiply 1.79 divided by 8.31 multiply 273 multiply 1000. So it is equal to 0.086. What I missed over there? 8.31 I have taken, so it is 0.08. Yeah, ठीक है, 0.08 it is taken. Why? 1 I have taken all the values correct, I think so. 1.79 I have taken. So I have taken 831, 8.31, all right, with the 473 Kelvin. What is this? 473 Kelvin. Just a second. It is 473. Really sorry, I was just messed up with the values. So it is 0.05. 0.05 moles over there. So this is calculate the number of moles of X are calculated, and value of N will be calculated by using general gas equation where R is general gas constant and remaining all the values are arranged for its calculation over there. Now he is saying calculate the relative molecular mass of X over there. So I will say here as the given mass was 3.5 and I have number of moles. So number of moles is equal to mass in gram over mR. So relative molecular mass is mR is equal to mass in gram is 3.5 divided by number of moles was 0.05. So we will say here that it is going to be taken fraction introduced 3.5 divided by zero point zero 0.05 will equal to 70 gram per mole. Now he is saying that that compound X contains 87.5% of carbon and 14.3% of hydrogen by mass. Calculate the empirical formula mass. So it's easy for carbon 85.7 divided by 12 and 14.3 divided by 1, and I can take the ratio according to by dividing the percentages by their molar masses. So I will say that it is going to be taken as we can say it can be taken as 12 7 times 84. So I'm saying it is the 7 and it is 14. So it is carbon, it is hydrogen. So it is approximately double CH2 can be taken as empirical formula for this. Should be available over there. Deduce the molecular formula of X over there. It means the molecular formula can be calculated by dividing the molar mass that was 70, and this 12 plus 2 is 14. 70 divided by 14 will give me 5. So 5 is the number which will be multiplied by empirical formula C5H 10 plus 2 12. So it will be C5H10. CH2 C5H10 will be fine for this. No need to add plus 2 over there. Now he is saying that a few drops of purple solution of acidified potassium permanganate KMnO4 were added to sample of liquid X and shaken. The solution remained purple state were deduced from structure X from this experiment over there. We can simply say here there is no color change, so there is no carbon to carbon double bond is present over there, and molecule is not unsaturated, so molecule is not alkene, and only carbon to carbon single bond are present and molecules are saturated. Hydrocarbons are available. Saturated hydrocarbons are available only over there. Identify the two names of two formulas, possible structural isomers of X using the answers from A, 4 and B over there. Then I will say one possible structural isomer which can be being taken by using the formula that it should be cyclohexane like that. So I will say that for example we are taking a cyclopentane like this: 1 2 3 4 and 5, this H2 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 can be being taken to show this type of structure over there, like it is cyclopentane. I can also go, he said to me, draw two possible structures. So then I can say it can be being taken by like a cyclobutane with one methyl group. 1 2 3 4, 1 2 3 4, H2 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 with one CH3. So I will say 1H I am decreasing here, and I am taking CH3 is attached over here. So overall, if I talk about all of this, then I will say the cyclobutane is the butane which is not saturated hydrocarbon and can be being taken as the general formula CnH2n can be used for cycloalkanes over there. Okay, in question number 25 over there, what is he saying? Let's go for this. He is saying that chlorine reacts with both alkanes and alkenes. Three steps in the mechanism of the reaction of chlorine with butane to form one chlorobutane. Step one, chlorine with that is called radical formation initiation. Then radical is going to act like propagation, and it is going on. Name the mechanism of step of this reaction over there. Then I will say it is free radical substitution. Free radical substitution over there. So give the essential conditions for one step to occur, that is UV light, okay, where chlorine is going to be broken down into radicals over there, that is called UV light over there. And for the third part we can say name the step illustrated by step 3 is called propagation. Here he is saying a different type of step other than the ones shown also occur in the reaction. Describe this type of step, including two possible examples which might occur in this reaction over there. Then I will say, what should we say about this? It is a termination step. It is termination step over there, we can say about it. Or we can say two radicals join together and with no radical on the product side over there, like two free radicals join to produce no electron lost or gained electron searching atom. And we can say one example of termination step can be taken by word steps over there, like you are taking that. If I add the example over here, two chloride ion with the radicals are going to make Cl2 over there. So this is called termination step over there. And a second example of termination step by word or word equation over there can be used to illustrate it. Then he is saying for part B over here, he is saying that chlorine is not a polar molecule but can react with alkenes through an electrophilic addition reaction. State what is meant by the term polar molecule and why chlorine is not polar. So we know that if we talk about polar molecules, then we should know that one end of atomic region which is slightly positive and the other which is slightly negative, showing the partial positive and partial negative ions, and there is a dipole moment and charge separation, and the electron density of the particle charge is concentrated around the end of the atoms of the region is unsymmetrical, then we can say there is an electronegativity difference between atoms, which is going to show some attraction over there. And I will also say chlorine is not polar because it has no electronegativity difference. As we know, if something is polar, then Cl and Cl, then electronegativity difference is zero. So whenever we talk the electronegativity difference is zero, we say that it is non-polar compound over there, and chlorine is asymmetrical and so slightly positive and slightly negative end they have, and no concentration of electron density is required for no charge separation to be present over there. Only this type of separations are done for this. Okay, let's move to part B over there, where he is saying explain why chlorine reacts with alkenes even though it is not a polar molecule. So I will say here the electrons present in double bond or pi bond or carbon to carbon double bond like that of alkene can replace can be replaced um, in the chlorine molecule in the chlorine molecule which induces a dipole. So uh, this was your question number 25. Let's move to our question number 26, and that is the last question of this paper. Okay, here he is saying sulfur hexafluoride is used in an electric power over there. Okay, and he is saying electric power industry as an insulating gas. It can be used in this way as it is very unreactive, and fluorine reacts with sulfur to form SF6. Impurities of S2F10 and SF4 also form and must be removed because they are too much reactive over there. Give the name of the compound S2F6. So I will say that it is disulfur, disulfur, disulfur decafluoride, decafluoride over there. Molecular S2F10 consists of SF5 units linked with SS bond. Complete the dot and cross diagrams of them. So I will say here that this F is making a bond with 1 cross 1 dot, 1 cross 1 dot, 1 cross 1 dot. Sulfur is one atom with other atom is making like this. Then I will say 1 cross 1 dot, 1 cross 1 dot, 1 cross 1 dot can be taken as a complete labeling. In the same way on this side, dot cross dot cross can be taken according to the complete formation of the labeling of the structure completely over there. Now he is saying dot and cross diagram of SF4. So cross for fluorine atoms. Okay. So SF4, 1, 2, 3, and 4. So fluorine having the 7 electrons in their outermost shell, dot from sulfur, cross from here. And sulfur is making by its dot, cross is for fluorine. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 8 and dot over there. So this is SF6, but F has the 6 electrons in its outermost shell over there. So this is F, this is S, this is F, this is F, and this is F, can be taken as the standard figure over there. After that, he is saying that complete the table showing the cycles. Okay, S of 6 is showing 90-degree FSH over there. So here we will have to show that it is being taken S2F10. So I will go with S2 with F10. So it is one up, one down, one diagonal like this, and one diagonal like this. So it is 1, 2, 3, 4, 5, and 6 over there. And for the other also I will have to complete the 6 bonds over there, but for this one I will have to add the 5 sulfur over there. That this is my 1 sulfur, and this is my second sulfur. 1, 2, 3, 4, and 5 will be being taken as the fluorine atoms to be attached over there, and it is also being taken as 90-degree to be taken over there. So we can also say he is saying SF4. Then I will say that it is S, and it is F and F over there. Then we can say it should be being taken as F and F. So this is the way where we can go for 90, 180, and 120-degree. 90-degree is correct, 180-degree is also correct, and 120-degree, if you write any one of them, is also being correct over there. And here, one thing more, ignore the lack of degree sign, like it is not written with the degree value. If some student misses, just ignore it. Justify the shape around the atom of sulfur atom with SF6 over there. Then I will say SF6 has 6 bonding pairs of electrons and no lone pair. Means SF6 has all bond pairs and 0 lone pair. And I can also say that sulfur SF4 has 4 bonding pairs of electrons and 1 lone pair. This SF4 has, uh, I can say, 4 bonding pairs and no lone pair over there, and 1 lone pair. So because of this different structure over there, the electron pairs repel to be as far away as possible, maximum separation according to Nylon and Gillespie's theory of Vesper theory over there. Okay, the last part of this question here, he is saying SF4 and S210 are reactive, but SF6 is unreactive. So just a reason why this, by considering the shape of the bonding molecule over there. So I will say SF4 has one lone pair of electron with the sulfur making for unreactive. So SF4 because of its shape, and S2F10 as SS bond are weak as compared to SF bond, so they show the reactivity, while SF6 has a strong, difficult to break SF bonds, and sulfur atoms is the smallest, so the six fluorine atoms hinder the attack of the sulfur over there. So overall, the structure which I have told here, that SF4 has a lone pair of electron on the sulfur, making SF4 more reactive. Means lone pair present makes it more reactive. And SF10 S bond is weak, and SS bond is long as compared to SF. So SF6 is a strong. So S2F10 is also easy to go for reactions. But if we talk about SF6 over there, it is strong and difficult to break. So we can say here that the sulfur atom is small, so six fluorine atoms hinder the attack of sulfur over there. So this was your whole paper, which I tried to explain. And if you are watching till end, thank you so much, and try to revise this paper on your notebook so that you can be much familiar with the preparation over there.